Welcome back to Speak Up English Hub, everyone.
Hey there. So glad you could join us.
We are so pumped to have you tuning in specifically for today's program, Listening Advanced English Practice for Fluency.
Yeah, we have a really wild topic lined up for you today.
I want you to picture this. It is the 19th century.
Setting the scene, I like it.
Right. And a group of men are sneaking around a dark, quiet graveyard in Austria under the cover of night.
Definitely up to no good.
Oh, absolutely not. They find the specific tomb they're looking for, they pry it open, and they end up robbing the grave of the legendary composer, Joseph Haydn.
Which is just crazy to think about.
It gets crazier, because here is the bizarre twist. They didn't want his valuables.
Right.
They didn't want his jewelry or anything like that. They literally stole his head.
Yeah, his actual skull. And the reason they took it is, well, it's just as strange as the crime itself.
Exactly.
Because these men were phrenologists.
Right, the bum breeders.
Exactly. At the time, there was this widespread, totally pseudoscientific belief that human traits, especially things like immense musical genius, would physically manifest as literal, measurable bumps on the skull.
They were searching a dead man's skull for genius bumps.
I mean, you can't make this stuff up.
You really can't. Now, spoiler alert for everyone listening, they didn't find any genius bumps.
No, they definitely did not.
But going through our sources today, it's just incredibly ironic, because if those grave robbers had access to modern MRI machines,
Yeah.
and if they could have somehow scanned a living, breathing version of Haydn's brain, they actually would have found something.
They absolutely would have, just not bumps on the bone.
Right. Modern science reveals that engaging with music actually leaves a massive structural impression on the literal tissue of the human brain.
And that physical transformation is exactly what we are exploring today. We're pulling from decades of dense neurological research.
Some really fascinating stuff in there.
Yeah, alongside a massive landmark 10-year project called the PROTECT study.
Which is a huge deal.
It is. We're looking at how interacting with music physically reshapes the brain's architecture, and ultimately how it acts as a remarkably powerful shield against age-related cognitive decline.
And our mission today is to figure out exactly how this biological magic actually works inside your head.
Because it really does apply to everyone.
It does. Whether you are a childhood prodigy who has been playing the cello since you were in diapers, or an absolute amateur picking up a guitar for the first time at age 50.
Or even just a dedicated listener who loves throwing on a good pair of headphones.
Exactly. We want to show you how to harness these cognitive benefits for your own brain health. You absolutely do not need to be a musical genius to get the rewards.
No genius bumps required.
Okay, let's unpack this, because the absolute best overarching analogy to keep in mind today is that learning an instrument is not just an art form.
Wow.
It is a full-body, high-intensity gym workout for your brain.
That is the perfect framework to use. Because when you create music, you are forcing the brain to do something incredibly taxing.
It's working in overdrive.
Exactly. You are demanding that it simultaneously coordinate auditory feedback, visual processing, microscopic fine motor control, intense, sustained focus, and emotional imagination.
All at the exact same millisecond.
Which is an insane amount of data to process.
It really is. So for you listening, we are going to break down how this mental workout functions step by step.
Moving away from those 19th century grave robbers.
Yes, let's leave the graveyard. Let's start with the literal hardware. What do modern scans actually show happening physically inside the brain of someone who practices music?
Well, we see literal biological remodeling.
Wow.
Over time, that mental workout stretches and builds the brain almost like a muscle.
Just from playing notes?
Yeah. Several major studies have found that professional musicians possess significantly more gray matter in certain regions compared to non-musicians.
Let me stop you there just so we are all on the same page. Gray matter is the actual processing tissue, correct?
That's right.
As opposed to white matter, which is more like the cabling, gray matter contains the neural cell bodies where the actual thinking, the physical movement control, and the memory storage happen.
Precisely. It is the raw processing power of the brain. But the workout doesn't just increase the sheer volume of those processors.
It doesn't.
No, it fundamentally alters how they communicate with each other. There is a deeply fascinating paper from 2010 that looked specifically at children.
Okay.
And it found that musicians who begin their training before the age of 7 develop a noticeably larger corpus callosum.
The corpus callosum. I have always pictured that structure like a massive superhighway.
Oh, that's a really good way to visualize it.
Like, it's connecting to incredibly busy, distinct cities. You have the left hemisphere of the brain and the right hemisphere, and the corpus callosum is that thick neural bridge of fibers carrying all the traffic between them.
That is a highly accurate analogy.
Yeah.
And we have to look at why that highway needs to get bigger for a musician in the first place.
Right. Why the extra lanes?
Well, think about playing the piano. Your right hand might be playing a fast, emotive melody.
Which involves the creative right hemisphere and specific motor cortex areas.
Exactly. Meanwhile, your left hand is keeping a rigid, analytical rhythm.
Doing its own completely different thing.
Right. And your eyes are reading complex mathematical divisions of time on a page, which heavily engages the analytical left hemisphere.
So the brain is just forced to pass massive amounts of data back and forth across that bridge in real time.
Exactly. And for those who start training before age 7, the brain responds to that heavy traffic by physically building more lanes.
And the dividends from building that superhighway early on are huge, right?
Massive.
Because research from 2014 suggests that learning an instrument early actually improves a child's second language acquisition.
And their nonverbal reasoning, too.
It's like the biological infrastructure is just better suited to handle any complex information you throw at it.
Even if it has absolutely nothing to do with music.
Exactly. But I have to admit, I'm a bit concerned for our listeners here, and frankly, for myself.
Uh-oh. Why is that?
Let me push back a bit. If that superhighway gets the most lanes added before the age of 7 because of childhood neuroplasticity.
Right, the sponge phase.
Yeah. Is it too late for adults to start building? Are we just entirely out of luck if we didn't suffer through piano lessons in kindergarten?
What's fascinating here is a concept brought forward by Professor Anne Corbett from the University of Exeter.
Okay, lay it on me.
She was a key author on that massive pro-text study we mentioned earlier. And to answer your question, no, you are not out of luck.
Oh, thank goodness.
She introduces this really vital concept called cognitive reserve.
Cognitive reserve. Break that down for us. How does that differ from just building a bigger highway?
Think of cognitive reserve as the brain's built-in agility and resilience. It is a biological stockpile of adaptability.
So sticking with the highway analogy.
Yeah, let's stick with that. As we age, certain roads or main bridges in the brain might suffer wear and tear, or they might get blocked by cognitive decline.
Like traffic jams or road closures.
Exactly. But someone with high cognitive reserve has essentially built a massive network of alternate side streets and detours.
Oh, I see.
You might not be bulking up the main corpus callosum superhighway at age 50 the way a 5-year-old does.
Right.
But Professor Corbett explains that learning an instrument as an adult is actually one of the most effective ways to actively lay down those new neural detours.
You are building resilience regardless of your age.
Exactly. You're building a backup grid.
That is incredibly reassuring. So because the brain is physically building this reserve, these detours and processing centers, I want to look at how that biological change translates into superior daily mental skills.
Because it definitely spills over into real life.
Right. Sitting down to play the guitar isn't just about nailing a song. A major study from 2020 suggests that musicians demonstrate significantly better executive function.
Yes, and executive function is basically the master control room of our daily lives.
The CEO of the brain.
Exactly. It is the area of the brain, primarily the prefrontal cortex, that is responsible for forward planning, organization, impulse control, and complex problem solving.
So it's the mental skill you use to organize a chaotic schedule or manage your time or strategize a complex project at work.
Exactly. And the benefits don't stop there.
What else is there?
A comprehensive meta-analysis from 2017 concluded that musicians simply have a sharper, more reliable working memory.
But here's the thing that I find absolutely wild about all this.
What's that?
These are not musical skills.
No, they really aren't.
They are pure survival and professional skills. Being able to plan effectively, control impulses, and remember crucial details, that is just the definition of being good at navigating adult life.
It really is.
So how does practicing scales translate to being a better project manager?
Well, if we connect this to the bigger picture, the underlying mechanism makes perfect sense.
Tell me how.
Think about the overlapping data streams your brain has to manage when you play a piece of music. Let's say you are sight reading a new piece.
Okay, I'm looking at the sheet music.
Right. You are taking in visual data from the page. Then you are translating those visual symbols into precise, timed motor functions in your fingers.
Yeah, moving my hands to match the notes.
Simultaneously, your auditory cortex is actively listening to the pitch and rhythm to ensure you didn't make a mistake.
Which creates a real-time feedback loop.
Exactly.
It's like running on a treadmill while doing a crossword puzzle while someone grades your posture in real time.
That is a brilliant way to put it. Musical training forces the brain to process all of those overlapping streams flawlessly.
Wow.
And by constantly engaging in that extreme high-level coordination, the brain essentially cross-trains itself.
Oh, I love that term, cross-training the brain.
Yeah. It accidentally makes itself brilliant at organizing the chaos of everyday life. The neural pathways used to juggle the rhythm, pitch, and fingering of a difficult musical passage are the exact same pathways used to juggle a complicated, multi-tiered project at the office.
Because the brain doesn't know the difference.
Right. It just knows how to manage complex inputs efficiently.
That makes so much sense when you explain the mechanism like that. And since music cross-trains these lifelong cognitive skills, it naturally acts as a defense mechanism against age-related decline later in life.
Which brings us back to the PROTECT study.
Yes, and we really need to emphasize the sheer scale and gravity of this research for our listeners.
It is a landmark piece of scientific literature. The PROTECT study has been running for 10 years, and it involves over 25,000 people.
25,000. That is a massive pool of data.
It really is. For this specific inquiry into music, the researchers, including Professor Corbett, reviewed cognitive data from over 1,000 adults who were over the age of 40.
They wanted to see the specific effect of playing a musical instrument or even singing in a choir on overall brain health as we age.
Right. And the findings are stark.
What do they find?
Continuing to play an instrument into later life is definitively associated with a sharper, more resilient brain.
It specifically preserves verbal working memory, right?
Yes, and that all-important gray matter volume we talked about earlier.
And reinforcing that finding, there was a separate meta-analysis from 2021. It found a direct, measurable association between music practice and a dramatically reduced risk of developing dementia.
The protective lifestyle benefits are undeniably clear in the data.
But, our sources do point out a slightly naughty scientific question that still needs to be fully unpicked by future studies.
Ah, yes, the eternal enemy of observational research.
The classic correlation versus causation dilemma.
Exactly. The lingering question in neurology is this. Do these findings arise because musical brains are naturally more robust and resilient from birth?
Meaning those people just naturally have the brain power to continue playing into old age.
Right. Or is it because the actual mechanical act of playing the instrument causes the resilience?
Right. Do people without dementia just keep playing longer because their brains are intact, or does the daily workout of playing actively keep the dementia at bay?
It's the ultimate chicken and the egg scenario.
It really is. But honestly, regardless of which comes first, the association is so undeniably strong. And here's where it gets really interesting.
Oh.
Think about standard public health campaigns. When we talk about healthy aging, the conversation is almost exclusively about eating your vegetables, going for a walk, and maybe doing a crossword puzzle.
Very true.
But based on Professor Corbett's advice, the findings indicate that musical education should be treated as a major public health initiative.
I completely agree.
Doctors should literally be prescribing piano lessons to older adults as part of a healthy aging package?
It is a profoundly compelling idea. Encouraging older adults to return to an instrument they abandoned in childhood, or to start entirely fresh, could be a highly proactive, non-pharmaceutical way to reduce dementia risk.
And promote overall brain health. Which naturally leads to the next logical question for anyone listening.
Which is?
Well, if a doctor were to prescribe an instrument for your brain health, does the specific instrument matter? Do you get a different cognitive workout depending on the equipment you choose to play?
It appears you actually might.
Really?
Yeah, a very recent study from 2024 looked at 1,100 older Britons and broke down the cognitive benefits by the specific category of instrument they played.
So they separated the drummers from the flute players?
Exactly. And the specific mechanisms of each instrument seem to target different areas of the brain.
Okay, let's break this down. What is happening in the brain if you pick up the piano?
The study found that pianists, along with brass players, tended on average to have significantly better working memory.
Working memory.
Okay. And if you think about the mechanics of the piano, it makes total sense. A pianist is constantly holding multiple streams of information in their mind.
Right. They were reading a bass clef for the left hand and a treble clef for the right hand.
Exactly. Tracking multiple independent voices and harmonies simultaneously. That places a massive healthy demand on the brain's working memory capacity.
You are holding and manipulating all that architecture in your mind over short periods.
Got it. So what about woodwind players? Say, someone playing the flute, the oboe, or the clarinet.
Woodwind players actually possessed superior executive function.
That forward planning and problem-solving area we discussed earlier.
Exactly. Think about what a clarinet player must do. They aren't just reacting to the single note in front of them.
What are they doing?
Their brain has to look a full measure ahead, calculate the exact lung capacity required to reach the end of the phrase, and plan the precise micro-movements of their fingers.
While blowing air into a tube. Right. And they have to adapt their embouchure, their mouth position, in real time to keep the instrument in tune. That requires extreme forward planning and impulse control.
That is so fascinating. And what if you don't use a physical instrument at all? What about the singers?
Singers actually excelled in verbal reasoning.
Which aligns beautifully with the fact that their instrument requires them to constantly process lyrics.
Lyrics, linguistic nuance, breathing, and pitch all at once. They are constantly exercising the brain's language centers.
Okay, now I have to ask about the show-offs.
The show-offs.
You know, the people who play the piano and the trumpet and the saxophone and they sing, they must have absolute super brains, right?
Interestingly enough, no.
Wait, really?
Yeah, the study found that the multi-instrumentalists, your show-offs, enjoyed absolutely no extra neural benefit over the single instrument players.
Wait, I have to stop you there. I want to challenge the logic on that.
Go for it.
If music is a brain workout, shouldn't learning 3 different instruments give you 3 times the benefit? Like doing a CrossFit routine with different exercises, why doesn't that compound?
It comes down to cognitive ceilings.
Cognitive ceilings.
Yeah. Your theory is actually supported by the researchers in a way. But the brain simply hits a ceiling of cognitive benefit once it masters the complex underlying coordination.
The coordination of translating a musical concept into a physical action.
Precisely. Once you have built that fundamental neural infrastructure, that ability to translate visual notes into motor movements and auditory feedback, adding a second or third instrument is largely just using the same superhighway you already built.
Ah, so it makes the additional instruments redundant for brain health.
Basically, yes. The heavy lifting is already done.
You don't necessarily build new muscle mass by doing a bicep curl with a red dumbbell instead of a blue one. The fundamental tension is what counts.
Exactly. The core cross-training has already taken place.
Well, that is a relief. So for everyone listening, pick your weapon, but don't feel the need to conquer the whole orchestra to save your brain.
Just stick to one you enjoy.
Now, moving beyond the purely logical and cognitive tasks, we really must address the emotional and physical realities of aging. Because music doesn't just act on the structural wiring of the brain.
No, it heavily influences the brain's active chemistry, too.
It profoundly alters our neurochemistry.
It really does. When you play an instrument or even just engage deeply with music you love, it lights up the brain's limbic system.
And the limbic system is that deeply ancient evolutionary part of the brain that processes pleasure, emotion, and reward.
Right. And when you are in the zone, flowing with the music, your limbic system triggers the release of endorphins.
And endorphins are those wonderful feel-good hormones.
Yeah, they are.
But they don't just make you happy. They actually act as the body's natural painkillers, binding to opioid receptors in the brain. Which leads us to a truly mind-blowing study from 2025 regarding actual physical pain management.
This was a very visceral, direct experiment.
Very direct.
Researchers took 40 participants and injected them directly in the hand with a specific compound.
A compound designed to mimic severe delayed onset muscle soreness.
Yes.
I am visibly cringing right now just thinking about that. A literal pain injection.
It sounds medieval, certainly. But the clinical outcome was incredible. They found that the subjects who had musical experience literally reported feeling less physical pain from the injection than those without.
The title Music as Medicine is not metaphorical here.
Not at all. The neurological changes from musical experience and the brain's ability to trigger those endorphins seemingly alter the actual biological perception of physical pain.
It's staggering. Your brain gets so good at releasing these natural painkillers that you literally feel less of the injection.
It's a powerful tool.
And the emotional stress-relieving benefits extend far beyond just an individual playing alone in a room. Performing in a band, an orchestra, or a choir fundamentally eases stress and encourages powerful social bonding.
Which is so important.
In fact, the PROTECT study researchers noted that the social factors, the human connection of being part of a group, might be a major secondary reason why singing in a choir is so heavily linked to better brain health.
Human connection is undeniably protective for the aging brain. isolation is a known risk factor for cognitive decline. But this raises an important question.
What's that?
What if learning an instrument is completely out of reach due to arthritis? What if you can't play and you absolutely don't want to sing in a choir?
Well, there is incredibly good news for the dedicated fans out there. Another 2025 observational study looked at 10,000 cognitively sound individuals who were over the age of 70.
Yeah.
These people were not players, they were just regular listeners to music.
And the findings for those regular listeners were nothing short of astounding. They had a 39% lower relative risk of cognitive decline compared to non-listeners.
A 39% lower risk, just from regularly listening to music.
Now, we have to be scientifically rigorous here.
Yes, the sources are careful to point out that proof of a direct causal relationship remains elusive. We can't definitively say the act of listening caused the lower risk entirely on its own.
Right, there are confounding variables. It could simply be that people who actively listen to music also engage in other enriching, healthy behaviors.
Like reading or socializing.
Exactly. But even as an association, a nearly 40% lower relative risk is a massive statistical signal.
It really is.
It proves that the neurological processing of complex sound waves is doing something highly beneficial. When you listen to a symphony, your brain is actively engaged in predictive processing.
It is constantly guessing the next note, right?
Yes, recognizing patterns and tracking harmonies, which keeps those neural pathways firing even without the mechanical act of moving your fingers.
Because active listening is still a workout for the auditory and analytical centers of the brain.
Absolutely.
So what does this all mean for you listening to us right now? Let's bring this entire journey together. We started with the bizarre historical myth of phrenologists looking for genius bumps on a stolen skull.
A very weird piece of history.
But the scientific reality we've uncovered is infinitely more exciting. Music is a literal full-body workout for your mind.
It actively builds gray matter and strengthens the superhighways connecting your brain's hemispheres.
It creates a powerful cognitive reserve, a network of mental detours that shields you against dementia and preserves your memory.
It trains your executive function so you can better manage the chaos of daily life.
It literally lights up your limbic system to release endorphins and reduce physical pain. And whether you play the piano to boost your working memory, the flute to hone your problem solving, or just listen deeply to your favorite albums, you are actively protecting your brain.
And perhaps the most encouraging takeaway from all this research is that consistent engagement correlates with massive brain reorganization in enthusiastic late-in-life amateurs, just as much as it does in seasoned, lifelong professionals.
Exactly. You do not need to be a prodigy to feel the benefits of deliberate and regular practice. Though I will say, if you do decide to pick up an instrument today and you somehow become the next Joseph Haydn, you should definitely consider hiring a security guard for your tombstone. Phrenologists might be a thing of the past, but it's always better to be safe than sorry.
A very practical, evidence-based takeaway.
Before we close out today's program, we want to leave you with a final, provocative thought.
Something to mull over.
We have spent all this time discussing how the immense cognitive benefits of playing an instrument stem from the rich, simultaneous coordination of touch, sight, and sound.
The physical feedback of pressing a piano key, the breath control of a woodwind, the fine motor skills of bowing a violin.
But look at where technology is rapidly taking us. What happens to the brains of the next generation who might entirely create music digitally?
That is a fascinating question.
If a child creates a symphony by simply clicking a mouse on a screen, dragging loops on a tablet, or typing prompts into an AI generator, will they still get that same neuroprotective full-body brain workout?
It really makes you wonder.
If we remove the physical friction of the instrument, are we slowly losing a vital evolutionary tool for our brain health? Something for you to ponder until next time. Keep your brains active and keep listening.
Thanks for being with us. See you on our next video. Let's speak up.